we are going to start the geological map patterns. And as you guys remember, yesterday we did an exercise of contour maps where I have given you few points. You can also see the video, the last video on the channel, and then you can also follow the steps for today's class, that is the geological map patterns. Actually, we have two things on some of the maps that we do for exercise. One thing is contours. Contour, yeah, you guys know, they represent points of equal elevation, and we draw some points yesterday based on some values. And as you guys remember, the contour lines don't intersect each other, they don't cut across because they are points of equal elevation. Similarly, in some of these topography turned geological maps, they have a very significant type of patterns. We call them the geological map patterns, and they help you identify the strike and dip of the strata and how the rocks are overlying and underlying each other. We will see some of these criterias and try to understand what they mean. Remember, in a geological map pattern understanding, you need a 3D view, you need a block diagram so that you guys can see and analyze how a geological structure can look like in 3D and how it looks like in a map view. As you guys remember, we did we saw some images in geomorphology. In that, you saw the satellite images, and in those satellite images, you see the plane view. Plane view is that you take it from the top, and the cross-sectional view is that when you cut across something with a knife, and then you see the layers, the vertical layers present in it. Let's go step by step and trying to see some of these exercises that hopefully you guys will do yourself after understanding some of these criterias. So the map patterns and are very useful tool when you go to the field and you have some maps where you have contour lines and you have the geological context. Like you use the topographic map as a base map for your geological mapping, and with that way you can see different lines. Mostly topographic lines or the contour lines are represented by dotted lines, and the contact lines are mostly they are marked by the solid lines. So we have some of these planar structures like bedding, faults. Planar structures are those, remember, that have their presence in 3D, and they are penetrative and they can be seen in 3 dimensions. Those are called the penetrative structures. We have bedding planes. As you know, beds are the basic unit of a sedimentary rock or a layered rock. And similarly, we have faults. Faults are the when the layers are cut across, the layers are disturbed and they leave a significant pattern of 3D features on 3D features. Similarly, when we have the folded strata, the layers are folded, and as a result of those folding, we also have the limbs of the fold and the hinge of the fold into 3D. So it is very interesting, and it's very important if you want to become a geological modeler, if you want to become a geological mapper, if you want to join some agency that makes maps for the country, for the survey of Pakistan, the geological survey of Pakistan, the Comprehensive Mission, and other areas where you guys can utilize your capabilities. Similarly, the Power Development Authority, the POPTA, and when you are constructing big dams like the Pasha Dam, the Diamir Pasha Dam, and all these dams, you can utilize your skills, and you can understand the topography as well as the map patterns, and understand the third dimension. That is very helpful because normally the maps that you see are 2D. They don't have three dimension. But in these examples and in these coming examples, we will try to see some of these comparison between the 3D shape and the 2D shape, the paper shape and the model shape, so that you guys can appreciate the sense. Okay, the first figure, you can see that there are a number of beds, one, two, three, four, and these beds are horizontal. They don't have any dip. They just are lying horizontally. It means there haven't been any tectonic forces or there is no tilting. There is nothing. So these are just like the sedimentary rocks that was deposited in that area, and you can see that there is no layer cutting across, there is no dike, there is no sill, there is no fault, there is no fold, and it's just like calmly lying a horizontal strata. And this is the top view. Like in the map you will just see this top view. The pattern that you will see will be just one layer, the top layer, because the when you are taking a photograph or you are making a map on the surface of earth, you will just see this layer. You cannot see these layers, the horizontal layers. And based on that pattern, the map will show you just a single layer without cutting or any fault, any fold or anything else. But this is how you identify the horizontal beds. So we call these as horizontal beds. So remember, this is a block diagram in which you can see the three dimensions of an area, and this is a map in which you can see just two dimensions, the x and y. You cannot see the z, the depth or height, whatever you can call it. And it presents a flat topography. It doesn't have any dips or any other features. Now we see there are some bedding contexts that are present as a series of parallel contexts in a map view. It can happen like if there is a stream that is cutting an area of horizontal strata, and then you can have a map pattern and you can trace the context. But if the strata is horizontal, the pattern of the map will also show you some very good indicators, and you can see the map and you can understand based on the map that how the thickness of the strata is changing and how different layers are present in that particular area. So the areas can have shallow slopes or it can have a steeper slopes. Steeper slopes means almost vertical slope, and shallow slope or gentle slope means very gentle slope, just like you guys remember from the yesterday example of Saint Mary mountain, where we have a very gentle slope on one side and very steep slope on the other side. This is a very interesting diagram that represents the block diagram of 3D. These dotted lines are actually the contour lines, and these darker lines are the geological context. So you can see geological context here, geological context here. So maybe there is this is layer number one, layer number two, and layer number three. So you can see gradual increase in height of the contours, and similarly as you move towards higher contour, you move towards the younger formation or the most latest stratigraphic unit. As you move away from this, you are moving towards a more deeper, or you are moving towards more older stratigraphic unit. So this is a block diagram. How you will represent it in the map? This is the example. Here we have the contour lines, 400, 300, 200. And now you can see that the context, these are the context. So we just are seeing this part. We cannot see this or the other five or six parts. We can just see the top view. And in the top view, you can just analyze, okay, we have one A, B, C, or okay, and then the contour lines, as you can see, are passing from the center. Similarly, the contour lines are passing from the center. So you can understand, okay, if somebody asks you what is the contact, what is the depth of contact, or what is the height of the contact of A and B, so 200 and 300, what comes in between? 250. So you can just roughly say, okay, 250 meters or 250 feet until 350 feet is the thickness, so it means 100, almost 100 feet is the thickness of this unit. Similarly, you can go on and do similar checks and try to understand the flight line beds. Or if there is a valley that cuts across a two sloped surface, slightly different orientations, we can also have this one. And that there are chances that the bedding intersect two walls of the valley at slightly different angles. We can have a V shape, and this V shape is very interesting, and we have some of the uh, diagrams that we will see shortly are indicating the presence of some of the features that are present as a result of the cutting of contour lines and the outcrop pattern. If you remember some of these rules, it will be very easy for you to do the geological mapping in future, whether you do it for your final year report or you do it for your project after you finish your degree, when you are in the field or you are in some government institution, so you are doing some geological mapping with the survey of that country, and then you can understand these map patterns are really really useful. And as you can see, for horizontal units, the V shape that forms is parallel to the contour lines, and therefore the V points upstream. Also note the difference between true and apparent thickness of the units. So we will see how these things will look like. You can see that here we again have horizontal strata, but in the center, the dotted line you see is actually a stream, and that stream is actually forming a valley. And now again, you can appreciate that thickness or the sorry the contour lines are almost parallel to the to the geological context. The darker are the geological contexts, and the dotted lines are the contour values. So again, even if you have a valley or stream cutting across the center of the valley, and it is cutting the floor, and as a result of that, you can see that the geological patterns and the contours are again somehow parallel. Let me see. So it is almost parallel to the contour lines. Okay. All these three examples, you can see if the strata is horizontal, the contour lines are more or less parallel to the geological contexts, and you can also see it here, you can also see it here, you can also see it here, you can also see it here. Okay, there has been some discussion on uniformly dipping planar beds. If the beds in an area are dipping, and you guys know, dip means that if the strata is not horizontal and it is actually having some inclination, and that inclination, when it intersects the topography of the area, it will impart different map patterns, and those map patterns are very helpful to understand the geology of the area. All the planar features, you guys remember, they have two features: strike and dip. If the bed is there, bedding plane is there, it will almost have a strike and dip. And just let us see the map pattern that we can find in a dipping layer. Oh, here we have a dipping layer, and A, B, C, D. You can see that this layer is dipping towards this direction, and when you have the map pattern of it, because we can just see the topmost view, so you can just see this is the map pattern. However, this is the block diagram or cross sectional view that shows the vertical relationship of these beds, and it shows the uh, relationship of these beds, and as a result, you can see that this just shows you the in the corner the layer number 2, or maybe layer number 3 if you count from the bottom. And then you can see that in the horizontal example, you can just see the top view. However, if you cut across the if the layer is cutting across, then you can see that it is present in this corner. So this is how we have different layers that are present in geological record, and how they impart their patterns on a map, and it is a useful tool to understand and appreciate this. So now we have another interesting planner feature, planner diagram, and you can see that here we have contour lines, and we also have the geological context. However, in this figure, the contact lines and the geological context are not parallel, as was in the last case, and you can see that and appreciate that these layers are dipping, and like this layer is dipping, and then this layer is dipping, then this layer is dipping, and these layers are dipping towards northeast. Like for example, this is the north, so roughly this is east, and slightly towards northeast, because the strike is northwest southeast. So this is, always remember, there will be north on the map, the top of the map you can find the north, and based on that you can understand the strike and dip. So this long line represents the strike, and this short point represents the dip direction. So this is the strike, that is almost northwest, southeast. This is the direction. Similarly, the same direction for this bed. And then once you plot these figures, or plot this block diagram into a map, you can see that the strike line is parallel to this line, because these are the bedding contacts, and these lines are representing the bedding relationship of various stratigraphic units. You can see that how different is if a layer is dipping, if a layer is slightly dipping, and if a layer is horizontally present, how the contact relationships of that particular strata varies. Similarly, we again have a planar dipping feature, and this is a block diagram, and you can see that there is a strata that is dipping towards west, and you can see that the strata pattern on the map as well. And then you can see that we have the contour lines of 300, 200, 400, and then these are the bedding contacts, and you can see that the V of the contour lines is uh, more steeper than the V of the bedding planes, and it represents that the strata is dipping towards the upstream. And similarly, you can see the map pattern map pattern of the same block diagram, and you can see that we again have the presence of the strike and dip symbols, and you can see that the strike is towards northeast southwest, and the dip is towards northwest. And then you can see that there is a stream coming in the center of the strata, and that stream is actually responsible for cutting through this valley. And due to the cutting action of this valley, we have two side slopes, and these two side slopes actually make the V shape pattern of the valley. And clearly you can see the contour lines and the geological context as well. Okay, for today I think we just stop here, because it's just like you also need time to